So now continuing on with parallelograms, we have a special parallelogram called a rectangle. All of the same rules apply as a parallelogram, but a rectangle, we have something that makes it special is that it has 90-degree vertices. So in a rectangle, all of my corners are going to be 90 degrees. That makes it a rectangle. Now, because of that, we do encounter some other properties for a rectangle. And it says here, of course, all the things that apply to a parallelogram apply to a rectangle because it is a parallelogram, but a rectangle, the diagonals are congruent. So not only do the diagonals bisect each other, just like a parallelogram, but we find out that they are congruent. So in this image, AC is congruent to BD, same length, which if they bisect in this image, if they were to bisect at point E, we would then know that all of these, AE, EC, BE, and DE are all the same length, okay, because they bisect each other. So those are just some characteristics that we can utilize for a rectangle. So here, looking at these properties, the coach is making a basketball team run a new drill along the diagonals of a court, and we know that the diagonals should be congruent. So FC and DB are congruent. And if BC is 94 feet, FC is, right here all along that, is 106.5. Find DG. Well, we know that, this is the same as this. So DG equals CG, and then we know that CG is 1/2 of the entire length of FC, so it is 1/2 of 106.5. And then so there is DG. So we end up, again, let me see here, DB equals, so looking at the information again, once we solve that, DG would turn out to be 53.25. So just using our properties and understanding the concept of a bisector, understanding congruency. Now here, I went ahead and tried to draw this, and it's not all that pretty. But our images may be a little bit hard to see on the backdrop, and this is basically a rectangular barn door. So they're showing us the diagonals, and it's hard to see on this image. So that's why I went ahead and just created this rectangle to show what this image looks like. I've gone and I have labeled them according to JS framing a barn door with X braces, okay? RT, this length right here is 3 feet, 3 9/16 feet. QR is 7 feet. Angle RTS right here is 65 degrees, and it says find the remaining measures. Well, I can really quickly tell you that this is 65 degrees. I know that this length is 3 feet 9/16. This is 3 feet 9/16. This is 3 feet 9/16. I know that this side over here is 7. Let me see. So let's see, did they give us, is that identify everything that we needed to know based on, the stuff we know about a parallelogram and a rectangle? So with that, let's see here. PS is 7. Okay, so PS is 7. SQ, right? Okay, that is going to be that entire length. So 3 9/16 plus 3 9/16, and some of you will use a calculator. That be 6 18/16, which is the same as 7 2/16, which is the same as 7 1/8. So 7 and 1/8. PS we said was 7. Angle QTR. So this angle measurement right here, we know is 180 degrees minus 65 because it's a straight line, which turns out that that angle is 115 degrees. And then TQR, this angle measurement right here, we want to find that one. TQR, well, I know that this is a triangle. This is a triangle. And I know, just thinking about what's going on here, that I have this value, and 115 should all add up to 180. So I have x plus 115 should equal 180. Doing my inverse operations, I have 2x is equal to 65. Divide by 2, and x is going to be 32.5. So it looks like that TQR is going to be 32.5 degrees. There you go. Just using those characteristics of parallelograms and rectangles to fill in the blanks. Using the properties again of rectangles, what do we know? Let's see, what if they told us? How about BAC, this angle measurement right here, is 3x plus 3 degrees. ACB, so this angle measurement right here, ACB, is 5x minus 1. And it says find the value of x. So examining this, if it's a rectangle, we know that that is 90 degrees. So we know then that this plus this are complementary. They equal 90 degrees. If you don't remember that, I know that this plus this equal 180 degrees. So we can do that equation, or we can just say that this plus this is equal to 90 degrees. And that's what they did. They said, we know that those two angles together equal 90 degrees. They did some substitution, and they substituted in the values. When they combine like terms, they said this is 8x plus 2 is equal to 90 degrees. They subtracted 2 from both sides. 8x is equal to 88. Dividing both sides by 8, and that is how they came up with x equals 11. So using that information allowed us to find those missing values. Let's see, what else do we know here? A quadrilateral, JKLM, is a rectangle. Wonderful. So if it's a rectangle, I know that all of these lengths are congruent. Let's see here, I got 3x plus 1, and then JL, this entire length, right, is 2x plus 9. So they want me to find MK. Well, MK, they want a number, right? So we know that this plus this, this entire length is equal to this entire length. So I have 3x plus 1 plus 3x plus 1, because this is also 3x plus 1, right? Equals 2x plus 9, equals that entire length. So this entire length, they said, was 2x plus 9. If this one piece is 3x plus 1, I know that I add those two pieces together or multiply by 2, whichever one you prefer. And I know that I have 6x plus 2 is equal to 2x plus 9. Subtracting 2x, 4x plus 2 is equal to 9. Hopefully I'm doing this right. Minus 2 from both sides. 4x equals 7 dividing by 4. So x is going to be 7 over 4, which is the same as 1.75. Okay, so in that case, if we substitute that back in, MK equals JL, which equals 2 times 1.75 plus 9, so that would be 3.5 plus 9, or 12.5. Now that allowed me to find that. Now it wants to look at angle measurements. So let me clear this up a little bit, get rid of some of that so we can look at what our angles tell us or show us. And it tells me that JNK, so this angle measurement right here is 5x plus 2 degrees. And then JNM, this angle measurement is 3x minus 6 degrees. And I know that these two angles together add up to 180 degrees. So I should be able to make them equal to 180 degrees to find out what the value of x is for part B. So making them equal to 180 degrees, I combine like terms. 8x minus 4 equals 180. Add 4 to both sides. This becomes 0. 8x equals 184. Dividing by 8 on both sides, x is equal to 23. So J and K would be 5 times 23 plus 2, and that is going to be 117 degrees. This should be 63, but let's check it. 3 times 23 minus 6 equals 69 minus 6, which is 63 degrees. And I knew this, because they should add up to 180 degrees together. All right, so proving that parallelograms are rectangles. Again, how can I prove it? If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Ta-da, that is the special thing that will get us there. So how can I prove that? We can use the distance formula. We can use the Pythagorean theorem. There's a lot of different ways for us to do that. Let's see here. AB is 50. BC is 20. CD is 50. AD is 20. And then the entire diagonal there is going to be 54. And the entire diagonal here is going to be 54. So prove that the ABCD is a rectangle. Well, my two diagonals are equal. So in this case, we said that AC is equal to 54. BD is equal to 54. So since my two diagonals are congruent, we have a rectangle. Okay, just being able to use those definitions and understanding them. Oh goodness. Let's see. Proof for the correct statements. We don't do this proofs, right? Tennessee is not requiring that. But given that PQRS is a rectangle and PT is congruent to ST, they want me to prove QT is congruent to RT. Okay. Well, if it's a rectangle, what do we know? We know that these are 90 degrees because all my corners are 90 degrees in a rectangle. If it's a rectangle, I know that opposite sides, as a parallelogram, opposite sides are congruent. And that gives me enough right there that I can prove that this measurement is the same as this measurement because I have two congruent triangles. I have side angle side of this triangle is congruent to side angle side of this triangle. Therefore, corresponding parts of congruent triangles tell me then that QT is the same as RT. So again, being able to use those definitions that we're talking about allows us to find out a lot of the information that we need. And then here, here's the coordinate plane, of course, because we're going to be using the distance formula here. And it says identify rectangles on the coordinate plane. Remember, rectangles, if my diagonals are congruent, that identifies it as a rectangle. So we have my vertices here where they've graphed them, and it says determine whether it is a rectangle by using the distance formula. Okay, first of all, it's a quadrilateral. So in order for it to be a parallelogram, they found the distance formula of the opposite sides, and they determined that my opposite sides were congruent, so that made it a parallelogram. Now, once we have a parallelogram, the diagonals have to be congruent for it to be a rectangle. So they did the diagonals of HK and GJ, and they determined that those two were both the square root of 50 using the distance formula. So therefore, we had a rectangle. Okay, that helped us there. Let's see. Looking at the quadrilateral in this example, I've gone ahead and graphed this because it's easier with a graph to look at. So the quadrilateral, here are my 3 vertices for my quadrilateral. Which following points would make A, B, C, D a rectangle? Right here. So which one of these, because I've graphed it, which one is going to make it a rectangle? If I go to 1, 2, 3, 4, 5, 1, 2, 3, that looks pretty good. Okay. If I go to 5, 3. If I go to 5, 2, this point right here does not make a rectangle, so that's not good. 4, 3, 4, 3, right there would not make a rectangle. And then 6, 3 would be over here. 6, 3 would not make a rectangle. So it looks like that first choice right there would have given me a rectangle appearance. So it's the only one that could have met the requirement. So again, sometimes graphing versus the distance formula makes things a lot easier. So with that, looking at rectangles, that special requirement is it's a parallelogram that the diagonals are congruent. And now we get a little bit of practice here.